morning, my dear students. My name is Sharma, working as physics lecturer in one of the reputed institution. Today, our concept is about straight line motion. Okay, so related to this straight line motion, based upon graphs, you will be definitely given one question. Okay, mains or NEET or NEET. In any competitive exam, you will be given one question. Okay, graphical part today we are doing, right? Now, so I hope all of you know about graph. So this horizontal line you call x-axis. So this vertical line you call y-axis. So intersection of these two is nothing but origin. Okay. Now suppose there is one problem. That is, there is one car. Okay. So this car is at rest. Say it is not moving. Say parking. Okay. So there is no change in the position of the car for 1 hour. Okay. So within this 1 hour, what is its displacement? Nothing. Zero. Because before 1 hour, it is at rest. After 1 hour also, it is at rest. So how you represent this through graph? Very simple. So time, the physical quantity time, you are taking it on x-axis. Okay. Velocity, you are taking it on y-axis. So is there any change in the position of the car before or after 1 hour? No. That means there is no movement. No. So as you are increasing the time, but you can see no change in the position of the car, means no displacement, followed by no velocity. So you can say it is at rest. So what is initial velocity of the car? 0. Okay. So you can say it is a straight line along positive x-axis. Okay. Now, suppose this car, say, at an instant covered some distance, say 40 kilometers covered in 1 hour. In the next hour also, let us suppose it is covered 40 kilometers. Next hour is also 40 kilometers. So what do you notice? Equal distances are covered in equal intervals of time. Nothing but you can say it is maintaining uniform velocity. So what is uniform velocity? So whenever distance covered by the body in a particular direction in a particular time is same. So first 40 kilometers covered in 1 hour. Next 40 kilometers is covered in 1 hour. 1 hour. So what do you notice? It is covered equal distances in equal intervals of time. That is nothing but uniform velocity. So here you see time you have taken on x-axis. Velocity you have taken it on y-axis. So is there any change in the velocity of the body as you are increasing the time? No change in the velocity of the body. That means it is maintaining uniform velocity. Okay? So acceleration is always change in velocity by time. No? dv or delta v by delta t. So here before 1 hour 40 kilometers, after 1 hour also 40 kilometers. So there is no change in the velocity of the body. That means it is 0, right? Because final minus initial acceleration means rate of change of velocity. So it is nothing but you can say 0. So remember, whenever a body maintains uniform velocity, acceleration is 0. Okay. Next, about the nature of the graph. You can notice that it is a straight line, right? parallel to x-axis. So you know, whenever a straight line is parallel to x-axis, corresponding slope is 0. No? So it is a straight line and slope of it is 0. Here slope is nothing but you can say acceleration only. No? How you define slope? Difference in y coordinate by difference in x coordinate. So here change in velocity by change in time. So that is nothing but 0. It is maintaining constant velocity. So remember, whenever a body maintains uniform velocity, that corresponding acceleration of the body is always equal to 0. Okay? Next. Now, about next one. Suppose time taken along x-axis and velocity taken along y-axis. Say the velocity of the body goes on increasing. Say in the first 1 hour, 40 km per hour. Okay, 40 km per hour. Next 1 hour, it is covered 50 km per hour. Means obviously it will cover more distance. Next 1 hour, say 60 km per hour. So in this way, velocity of the body is increasing. Say from the beginning. So in the beginning, 0 velocity. First 1 hour, 40. Next 1 hour, 50. Next 1 hour, 60. So what do you notice in this case? As you increase time, velocity of the body is also increasing. Okay? So we can say slope means acceleration is positive. Okay? So it is a straight line passing through origin. So what is the nature of the graph? Velocity versus time in this case. Straight line passing through origin. Slope is positive because it is started from rest. No velocity in the beginning. So whenever a body starts from rest, corresponding velocity will be 0 now. So that is why in the 0 second its velocity is 0. But as you increase the time followed by it is increased its velocity. First 1 hour I said 40, next 1 hour 50, next 60. So in this way velocity of the body is increasing. Okay. So in this case slope is positive. Nothing but you can say acceleration is also positive. Right. So it is a straight line passing through origin. So you notice one valuable point under this, that is whenever v versus t graph is plotted, so the slope of this graph gives acceleration. Okay, so difference in y coordinate by difference in y coordinate by difference in x coordinate now will give you slope. Right, nothing but you can say acceleration. Right, now about next concept. Now suppose there is one car at an instant, its velocity is 40 km per hour. Okay, in the beginning its velocity is 40 km per hour. So next 1 hour it is increased to 50, next 60, in this way. Okay, so here the car is not started from rest, it is having some velocity in the beginning itself. Okay, so that is you call initial velocity, right? So here it is having some velocity now in the beginning, so that is u, right? So as you increase the time, means this is at 0 second, its velocity is u. Okay, so in the beginning some velocity it is having. Okay, so as you increase the time followed by its velocity is also increasing. Okay, so at time t seconds its velocity is say v. Okay, now so slope of vt graph gives acceleration. That is nothing but change in y quadrant by change in x quadrant, right? So over here the intercept part on y axis, right? Intercept part on y axis itself gives initial velocity. Okay, so general form of a straight line is y equal to mx plus c. So slope, that means nothing but acceleration is positive. Why? Because velocity of the body is increasing, right? So y means over here velocity na, slope, acceleration. Okay, along x-axis you have taken time, so t, plus intersect part u. Okay, so v equal to u plus at. Now the area swept by this, area covered by this is nothing but displacement. How? Because you see, time you have taken along x-axis, velocity you have taken along y-axis. So the product of these two. Okay, so what is the definition of velocity? Rate of change of displacement. Cancel, right? Displacement. So it is very, very important. Area of VT graph gives displacement. So remember, area of VT graph gives displacement. Okay, so V versus T, nature of the graph is a straight line, not from origin. So the previous one from origin, that is it is started from rest. Over here it is having some velocity in the beginning, right? Next concept. Now you see, suppose you have taken a ball, it is projected up, okay, with certain velocity. So the moment when you are throwing a body upwards now, it will be moving against the gravitational force, right? So thereby its velocity slowly decreases. At a point it becomes zero. So here in the beginning the body is having some velocity, say u, right? So when you throw it up now vertically upwards, so velocity of the body slowly decreases. At a point it becomes zero, right? That is nothing but it reached to a particular height that you call maximum height. Remember the time taken by a body to attain maximum height. So this particular height time you call time of ascent. Okay, so the height attained by it called maximum height. Okay, so it is similar to a projected body. So whenever time taken along x-axis, velocity taken along y-axis of a projected body, vertically a projected body, velocity of the body decreases. No, velocity of the body decreases and becomes zero. So you can say negative slope, negative acceleration, nothing but you can say deceleration. No, because velocity of the body goes on decreasing. No, it is nothing but you can say deceleration. Okay, so these are all related to graphical part. Now based upon this VT graph, you will be given definitely one problem in any competitive exam. So under this you need to remember only two important points. What are they? One, slope of VT graph gives acceleration, because change in velocity by change in time, right? So acceleration. And area covered by VT graph gives displacement. So if you know these two, easily you can solve any problem. Okay, now we'll start problems based upon this VT graph. Now about the given problem, there is an elevator which is moving upwards with certain speed, that is 3.6 meter per second. Okay, so you want to know the height that raised by elevator after 12 seconds. Nothing but you can say its position, height. Okay, so you know velocity versus time graph, area is always equal to displacement. Now, so area of V versus T gives displacement. Nothing but you can say position. So the problem is there is one elevator moving upwards with speed 3.6 meter per second. So you want to know its position after 12 seconds. So you know this graph. So it is in the form of trapezium now. So you know area of trapezium is half h into a plus b na, height 3.6, right, into a and b. You know a and b are parallel sides na, so a 12, b between 2 to 10, no, so 12 plus 2 to 10, difference 8 na, so 20, right, so 3.6 into 20 divided by 2, right, so 36 meter, no, so the elevator is taken to 36 meters from the ground after 12 seconds. Okay, so remember area of velocity versus time graph gives displacement. Okay, now about the given problem. Velocity versus time graph you have given two questions under this. Find the displacement and distance traveled after 6 seconds. So you know area of V versus T graph gives displacement. No? So VT graph area, right, equal to displacement. Okay, so you want to find in 6 seconds. So area of this. So total area will give us displacement. But while calculating displacement, remember this area must be subtracted. Why? Because you know it is on negative side. So you know displacement is a vector quantity now. So that is why this is subtracted. But while calculating distance, no, you can add all the three areas. So first I am calculating displacement. So 0 to 2, length 2 na, and this side 4. So you know area of rectangle, length into breadth, no? So 2 into 4 minus this area is subtracted because you know it is on negative side, right? 2 to 4, 2, and this is also 2 na, 2. But this area is on the positive side of x-axis, so it must be added. 4 to 6, 2 na, and this is also 2, right? So cancel. 8 units, no, 8 meter is displacement after 6 seconds. Suppose you want to find the distance traveled. Okay, distance traveled in 6 seconds. You know, displacement is vector quantity, distance scalar quantity. So that is why all areas are added by calculating distance. Okay, so 8 plus 4 plus 4, 16 meter is a distance traveled and 8 meters is displacement. After how many seconds you want? 6 seconds. So this is equivalent to displacement and this is distance. Okay. Now about the given problem. The given problem is there is one body, okay, that is a stone thrown up with 30 meter per second velocity upwards. Okay, so the question is the maximum height covered by it you want to find. Okay, so the variation of its velocity versus time is represented through a graph. Okay, so in the beginning it is having 30 meter per second velocity. So as you increase the time now, you can notice that at 3 seconds its velocity is 0. That is nothing but you can say time of ascent, right? Time taken by the body to reach maximum height, right? So followed by it will be coming to ground only now. So when you are throwing a body vertically up, so here it has taken 3 seconds to reach maximum height. Then the body ceases its motion, no? It stops for few seconds, then again it will come to ground only, right? So question is how much height, no? The maximum height that it is covered, no? So that you want to find the height raised by the body above the ground, you want to know, right? So it is nothing but displacement now, displacement of the body from ground to the point, right? So displacement is nothing but area of VT graph now. So you have to consider up to 3 seconds only, because 3 seconds is the time taken by the body to reach maximum height. So he is asking only about maximum height, no? So area of this part, nothing but it is in the form of a triangle, half base into height, right? So half base 3 units, height 30, right? So 2 divides 30, 15 times now, so 15 3s 45. So 45 meters is the maximum height covered by it. That is when you are throwing the body, okay, upwards with 30 meter per second velocity. So you also notice that its velocity is decreasing. Why decreasing? Because it is moving against the gravitational force. That is why its velocity slowly decreases at a point becomes 0. So that particular height you call maximum height. Okay. Now about given problem. So it is one of the given question in mains last year online exam. See, the question is variation of velocity versus time graph is given and you want to know its position after 5 seconds. Okay, so a particle variation of its velocity with respect to time is given. You want to know its position after 5 seconds. So position is nothing but displacement, right? So displacement is nothing but area of velocity versus time graph, no? So area of VT graph gives displacement, but you want after 5 seconds only. So you take up to 5 seconds. Okay, suppose you want up to 6 seconds, take then up to 6 seconds. 8 seconds, take entire area. Okay, over here up to 5 seconds now, so take up to 5 seconds only. So you can divide into 3 parts: triangle, square, rectangle. Okay, So area of those three parts will give us position. First one, triangle na, base to height 2. Half base into height. Now next one you see 2 to 4, not 2. 2. So it is a square na, plus 2 into 2, all positive because no area given in the negative x-axis downwards. No? So that is why they are all taken plus only. Next 4 to 5, 1 na, touching at 3. Right? So 1 into 3. Okay? So 2 cancel na. 2 plus 4 plus 3. So 9 meter. So its position after 5 seconds is 9 meter. Same like elevator. But over there you have taken total. Over here you have mentioned a particular time, 5 seconds. Okay? Now about the given problem. So there is one particle moving in the positive direction of x-axis. Its variation, velocity with respect to displacement you have given. But the question is about the nature of the graph, v versus t. Means velocity taken along y-axis and time taken along x-axis. You want to know the nature of the graph. You have given relation between v and s. Okay. So you know velocity is equivalent to displacement by time na. So rate of change of displacement gives velocity. So ds by dt taken as k root s na, k root s. Right. So you bring this root s to this side. Okay. Now you integrate on both the sides. Okay. So ds by root s. So integration of ds by root s is nothing but 2 root s. How? That is this you take up first, right? So s power minus half. So minus half plus 1 by minus half plus 1. Nothing but 2 root s equal to k into integral dt. Integral dt is t na, right? So root s equal to kt by 2, right? Squaring on both sides. Okay, k square t square by 4. So this is about displacement. Okay, so why we are doing all these things? Because you have given question is about v versus t, but you have given v versus root s. So you have to find relation between velocity and time. So whenever displacement is known, further you differentiate, you get velocity, right? So displacement equal to k square t square by 4 na. Okay, now differentiate. Okay, so differentiating on both the sides. Now differentiate this equation, okay, with respect to time. Okay, then ds by dt. You are differentiating this equation with respect to time. Okay, so k square as it is now by 4, differentiation of t square 2t, right? So this divides 2 times now, and ds by dt gives velocity. So velocity equal to k square by 2, okay, into t. So now you want to know about the nature of v versus t graph. So velocity is taken along y-axis, some constant, into t taken along x-axis now. So it is a straight line passing through origin. Why? Because there is no constant term. So what is nature of V versus T in this graph? Nothing but a straight line. Okay. Now about the given problem. So there is one car started from rest. Okay. With constant acceleration alpha reaches a maximum value of velocity v. Okay. After some time its velocity started decreasing. So that deceleration is also given beta. Okay. If you have given t is the total time, okay, find the distance traveled by the body. So that is a question. No. So in the first half acceleration, next half deceleration. Okay. So you know total time of journey is t1 plus t2 na. Now t1, this part, that is acceleration known, velocity known. No? So you know acceleration is equal to velocity by time na. So it is nothing but you know t1 is equal to v max by alpha. Now second case, deceleration. No? That is v max by beta. Deceleration means negative acceleration, but time is a scalar quantity, no? So you need not take signs, right? So v max you can take common, then alpha plus beta by alpha beta is t na. Okay, now v max becomes, okay, alpha beta by alpha plus beta into t na. So you want to find the total distance traveled by the body, nothing but this area, no? So you know area of VT graph only gives displacement, right? So displacement or total distance traveled by the body in a particular direction is given by half base into height. Base, total time na, height, nothing but V maximum, right? So it is alpha beta by alpha plus beta into t. Okay, so total distance traveled is alpha beta by alpha plus beta into t square, right? So total distance traveled by the body, okay, you get S is equal to half, okay, t square of alpha beta by alpha plus beta. Okay, thank you for watching this video. Please subscribe, like, forward to your friends.